My name is Olin Williams, and I'm an architect in the Enterprise Technology Planning Group.
Adjusting R2, the 500K trim pot, we can change the time constant of this circuit, and we can see the change in the impulse response. For those of you interested in the theory, we're using the cross-correlation method of determining system impulse responses. It can be shown that the impulse response of a system can be calculated by cross-correlating a random noise input with the resulting output.
The Innovation Award recognizes the most inventive accomplishment of an IT employee. In anticipation of Southern Company's need to build a new monitoring system to prevent incidents like the Northeast blackout of 2003, Olin Williams developed an entirely new method, dynamic real-time power system monitoring, to survey the national electric grid for faults and problems.
I nominated Olin Williams' new idea based on his patent submission a couple of years ago, which we filed last year. It's a dynamic way to measure the power system. What it does is it uses complex mathematics based on ideas he came up with in the 1960s and patented. It took 40 years for computer technology to match Olin's brain.
The way that the technology works is through something called a stimulus response model, where we're injecting signals into the power system in a predetermined location and then reading those signals back out again, and then using that sort of map of what's going on in the system during a healthy state for the power grid. We can then compare that picture with real-time readings that we take as the grid is operating throughout the day.
What his technology does is send out an electrical impulse on the grid, similar to the concept of a sonar ping, where you'd send out a ping, get a response back, and from that you can create a map of what you see. Olin's technology works the same way.
Our traditional ways of monitoring the system in the past has been to actually use a computer model of the system and to give us some early warning signs. But this is revolutionary in that we don't have to use this model of the system. It's giving us real-time data.
Olin is one of the most creative people I have ever met. I really feel that he's an absolute role model for being passionate about your work and passionate about the use of technology in solving real business problems.
It's been great to work with Olin on this project. He cares very deeply about this technology and wants to see how we can apply it to the power system. He's also caused several groups in transmission that maybe normally wouldn't step back and think about different ways to apply this to the power system, he's brought those groups together, and we've really seen a collaborative effort in terms of ideas of ways we could use this on the power system.
Olin's innovation has the potential to impact far beyond just the company. It has the potential to impact how transmission grids are monitored across the world. It's that big a change.
Okay, the circuit we're using here has just classic RC circuit with a damped exponential response. There's a 10K here in the input leg and a 0 to 500K trim pot in parallel with a 220 microfarad capacitor that we can vary and change the time constant. The impulse response function is the 1 over R1C e to the minus R1 plus R2 over R1 times R2 times C t. After adjusting the trim pot on R2, the expected longer settling time of the impulse response is displayed. What you're watching in this video is the real-time calculation of a system impulse response of an RC circuit without actually hitting the circuit with a potentially damaging impulse. The impulse response of a system is important because it completely describes the system, but we'll talk about that more a little later. Olin is one of the most creative people I have ever met.
I really feel that he's an absolute role model for being passionate about your work.